Welcome to the eLearnSecurity video training. In this video, we will show you the difference between unencrypted communications and encrypted communications. You will see how easy it is to sniff credentials if you use insecure protocols like Telnet. First of all, let us see how to configure two hosts so that they can communicate with each other through Telnet. In the beginning, we will configure the ELS Telnet server, the one we saw in the previous animation. This is the endpoint, the one receiving the Telnet commands. So let us activate Telnet client and server services. To do that, open Control Panel, then uninstall programs, and then turn Windows features on or off. Let the window load all available services and then choose both Telnet client and server. Now we have to enable this service and set the logon option for Telnet communications. So we'll open Services, search for Telnet entry, and then open Properties. Go to the Logon tab and enable Local System Account. On the status column, be sure the service is running and is started. At this point, we're able to connect through Telnet to this machine. So let's focus now on the other side. We'll issue Telnet commands, that is the client. First of all, enable Telnet client service. To see the whole communication, we will open and start capturing packets with Wireshark. So let's open Wireshark and start sniffing packets on the interface that connects the two hosts together. We will sniff the VMware Virtual Ethernet Adapter interface because we are using virtual machines. To see only Telnet communications between the two machines, write down in the filter label the string Telnet. This will ensure that we only see Telnet traffic. This is what we want to intercept. Now that we have all that set up, let's start the communication. So let's open a command prompt and write Telnet and the address of the remote machine. In order to ensure that we have the right machine, let's check the IP address of the Telnet server we want to talk to. So let's open up the virtual machine with the running server and run the ipconfig command. We can see in our scenario that the address is 192.168.88.131. So let us try the connection. Here we can type in our destination address. Once we are connected, Telnet asks us to insert the remote host credentials. So insert ELS as username and the password. Now as you can see, we are connected. Let's run a command, say directory, dir, and we can see the response. For the sake of clarity, we will open the directory in the remote host to prove that we are actually listing contents from the remote server. Since this communication is unencrypted, let us now examine the sniff traffic we have in Wireshark to see if we can get successful information. Within Wireshark, thanks to the filter, it is only showing us the Telnet communications. Let's analyze the content. Just go to the beginning of the communication. Here we have some messages between the host and server. Here we can see the request of our logon credential coming from the server. Let's try to connect again to see if the request is the same. As you can see, it is. The packet contains the request for credentials. So we are supposed to have login credentials in the following packets. And so it is. As you can see, we have the E, the L, and the S. So let us write down this information. After that, the server asks us to insert the password. So let's see what we can get from here. We can see again all characters typed from the host. We can see that our password is mystrongpsw. Furthermore, we can see the command dir sent to the server. You can see here as we start to type the command, we see the D, the I, and the R. As you can see here, the communications is completely unencrypted. So how can we avoid this? Let us focus on the following scenario. You are on an insecure network like an internet cafe or a hotel Wi-Fi network, and you don't want to expose your traffic to local attackers. Your goal is to build a secure tunnel from your machine to a machine that you own outside the insecure. This machine will act as your tunnel endpoint and will make sure that you only exchange encrypted traffic up to it. We want to have a secure Telnet connection on the ELS machine, exploiting the capabilities of an SSH tunnel. How do we create the tunnel? Let us see now how to configure an SSH tunnel between the Windows machine and the Backtrack 5 machine. As the SSH peer running the SSH daemon, we will use Backtrack 5. In Backtrack 5, you already have OpenSSH Server. As a matter of fact, if you type sudo apt-get install OpenSSH Server, you will get the following message. What you need to do to get it working correctly is to generate private and public keys. So we write into the terminal sshd generate. This will automatically generate private and public keys. Once it's done, you need to restart the SSH server. To do this, write down sudo /etc/init.d/SSH space restart. Now you are ready to use the SSH server to tunnel your connection. Now we will go back and start Wireshark on the SSH server. This allows us to prove that an encrypted tunnel is created between the Windows machine and the Backtrack 5 machine, while a regular unencrypted connection will happen between Backtrack 5 and the ELS machine. Let's move on with starting PuTTY on the Windows machine, which will be the SSH client. PuTTY is one of the most famous Telnet and SSH clients for Windows. So let's see how to start an SSH connection. In the Session tab, insert the IP address of the SSH peer you want to connect to. With an ifconfig on the Backtrack 5 host, we can see that the IP address is 192.168.88.132. So we will insert it into PuTTY and leave port 22 as the default port. This is the default port for SSH. Now let's see the IP address of the ELS virtual machine, always the endpoint of the communication. Since it is a Windows machine, let us use the ipconfig command from a command prompt. And as we can see, the IP address here is 192.168.88.131. Now we go into the Connection tab of PuTTY and open SSH and then Tunnels. Here add a port, say port 3000. It should be a high port range above 1024, and insert the endpoint IP address. It's the address we've just got from the ELS virtual machine. Okay, now we're ready to start the communication. Press open and see what happens. Once the connection occurs, we see we are prompted for the credentials for the SSH server. Now we are into the SSH server. Now let's try a Telnet connection with the ELS Telnet server at this point. Once again, we will do this by typing telnet 192.168.88.131, and then we'll see as before, once it's connected, we are asked for our login credentials. So let's insert those. And as you can see, we have made our connection and we are in. Through Wireshark, let us take a look at the differences between the previous scenario and the current one. Let's first analyze the whole SSH and Telnet communications between the Windows machine and the SSH server on Backtrack 5. To do this, we have to set the right filter on Wireshark, so let's see how to do that. Since we only want to see SSH and Telnet protocol communications, first of all we specify SSH or Telnet as the display filter. Then we specify the IP source and the IP destination. This way we are ensured that we only get the communications from the Windows client to the server. Once we've entered that, we see that these are the results. One can think that there is something wrong because no Telnet protocol is shown. So let's stop a moment and think why this is happening. From the host to the server, we are going through SSH. That is an encrypted connection, and absolutely no Telnet communication should appear in the clear. So the only thing you will see here are encrypted packets into the SSH protocol. You can understand why this is called a secure connection. Let's see now the communication between the SSH server and the Telnet server, which is the ELS virtual machine. Remember that this communication is unencrypted. No SSH protocol is in place. To verify this, we'll just change the filter parameters in Wireshark. So change the IP source and the IP adder to match the IP addresses of the Backtrack 5 host and the ELS Telnet server. As you can see, instead of the SSH protocol, we see the Telnet protocol, where the whole content of the packet is unencrypted. As a matter of fact, you can see here the credentials, login, and password. But this is what we wanted to see, because we trust this link between the Backtrack 5 and the ELS virtual machine. Once again, we can write down the characters that we have sniffed. We have first ELS, then a return, then my strong PSW is the password. But we have a secure link, at least for the insecure network. We can also see the directory command that we created. This concludes our demonstration of using secure versus insecure protocols. Thank you for joining us.